Welcome to LabVIEW NXG Core 1, Acquire, Analyze, Visualize. In this course, you will learn how to create an application that acquires data from hardware, analyzes and processes that data, and then visualizes and logs that data. Along the way, you will develop, debug, and test LabVIEW NXG programs. Additionally, you will learn best practices for code reusability and readability, as well as error management. You will also develop an application that implements a sequencer using state diagram logic. To get started, you will need a computer running Windows 7 or later, LabVIEW NXG, the DAC-MX driver, and the NI Visa driver. You will also need to set up simulated hardware that mimics a NI compact DAC device in order to complete the exercises. I'll walk you through the process of setting up your simulated hardware later in this lesson. You will also need the LabVIEW NXG Core 1 exercise instructions and exercise files available for download here. For this course, you will use simulated hardware to acquire data. You will configure an NI-CDAC 9178 chassis with the following modules: an NI-9236 strain or bridge input module, NI-9213 temperature input module, NI-9472 digital output module, NI-9263 voltage output module, NI-9234 sound and vibration input module, NI-9215 voltage input module. Click each module to learn more about it. In this demonstration, we'll walk through the process of configuring the simulated hardware required to complete the course exercises. From the Start menu, open LabVIEW NXG and select Use Your Hardware. This displays the System Designer. Select your PC in the System Designer LabVIEW workspace and click the Launch NIMax button in the Item tab. In NIMax, expand the Devices and Interfaces item. Then click Devices and Interfaces and click the Create New button. In the Create New dialog box, select Simulated NI DAC-MX device and click Finish. The first thing you'll add is a compact DAC chassis. Under Compact DAC Chassis, select NI-CDAC 9178 and click OK. Now you'll configure the simulated chassis with the modules you need for the course. Click the Configure Simulated CDAC Chassis button and begin adding modules. In slot 1, add the NI-9236. In slot 2, add the NI-9213. In slot 3, add the NI-9472. In slot 4, add the NI-9263. You'll skip slots 5 and 6 since we're setting up the simulated chassis to match the CDAC demo kit used in the classroom training. So now you'll add the NI-9234 in slot 7 and the NI-9215 in slot 8 and click OK. You should now be able to see your simulated compact DAC hardware under Devices and Interfaces, and mine is named CDAC1. Now you can close NIMax and you will see your simulated NI compact DAC hardware in the LabVIEW NXG System Designer. Now, your simulated hardware is ready to use when you begin the exercises. This course uses a variety of instructional methods. One of the best ways to learn LabVIEW NXG is through the hands-on exercises. Keep these suggestions in mind as you work through the course exercises. Experiment with hands-on exercises to better understand the methods used. Complete the challenge, your turn, and putting it all together sections of the exercises. These sections have only high-level instructions and let you practice the skills you've learned. Explore the solutions. Keep in mind that these solutions provide one possible approach. You may find a better one. LabVIEW NXG Core 1 along with LabVIEW NXG Core 2 will help you prepare for certification exams. This course is organized in 3 main sections. Lessons 1 through 3 teach you how to begin interactively acquiring measurements from hardware. In lessons 4 through 10, you will learn how to create an application that acquires, analyzes, visualizes, and logs data. In lessons 11 through 13, you will learn best practices for code reuse and code readability. And in lesson 14, you will learn how to put it all together to implement a sequencer for all the tasks in your application. Additionally, in Lesson A, you can learn about advanced file I/O techniques. You've completed this module. Here is a summary of what you've learned.